Okay, so this chapter was chapter 5 over electrons and atoms. And in section 5-1, it was over the models of the atom. And I didn't know much about the atoms or how everything worked or how the path of moving electrons was. So when we try connecting it to our world, it gives us an example that engineers use wind tunnels and scale models to simulate and test the forces from the moving air on each proposed design. Not all models are physical, though, like this one. And in many models of the atom, it has been developed over the last few hundreds of years. In this section, we learned about the currently accepted model of how electrons behave in atoms. So like this picture right here to the right, it shows the path of all moving electrons. And then on the picture of the left, it just shows the rings and where the protons and neutrons are, which is in the center. And then there's two rings around it, which shows the electrons and the positives and negatives of the carbon of the atom. So that helped me understand how that works more. And then we go on to section 2, which is the electron arrangement inside the atoms. And when connecting this to our world, it is the arrangements are rare in nature because they are unstable, which is right because nature is always changing. Unstable arrangements like sand in a sandcastle tend to become more stable by losing energy. Like if a rock were to tumble over, it would end up at a lower height. It would have less energy than before, but its position would be more stable, which makes sense when picturing a rock falling down a hill, because it would be more stable at the bottom of the hill. Energy and stability play an important role in determining how electrons are configured in an atom, which also makes sense when thinking about how atoms and electrons work. This is just an example that was in our book, and it's a chart to help us understand this part more. And then we move on to section 5-3, which is physics and the quantum mechanical model. I had never really heard of the quantum mechanical model. Then again, I'm not really the science-y type, so I wouldn't be a good person to ask about this, but I did learn about the quantum mechanical model, and now I do understand how that works. And when connecting this to our world, it's like if you walk in the evening along a busy street lined with shops and theaters, you are likely to see neon advertising signs, like in restaurants and stuff, that say open or etc. The signs are formed from glass tubes bent in various shapes, and an electric current passing through the gas in each glass tube makes the gas glow with its own characteristic color, which is like a lab, which we did in chemistry for 5-3 with the changing of the gas colors. In this section, we learned why each gas glows with a specific color of light, which was very interesting, and I really liked this lab, which we had to watch videos over. The electromagnetic spectrum consists of radiation over a broad band of wavelengths, just like the picture shown to the right. The visible light portion is very small. This shows the electromagnetic spectrum and the wavelengths and the frequencies and what the colors will end up being, which I find very interesting. A prism separates light into the colors it contains. For white light, this produces a rainbow of colors, and light from a helium lamp produces discrete lines, which is an example to the left and shows how that works. And then down here, we have before picture of collision and an after picture of collision, and as you can see, you can tell the differences between the two. Before the collision, a proton strikes an electron during an attempt to observe the electron's position, and after the collision, the impacted changes the electron's velocity, making it uncertain. And this is just an overview of what we have done in chapter 5 over the atoms. And that is the end of that.